Hello my dear students, how are you all? Welcome back to the channel. Today I'm starting with session number 2, the part 2 of the chapter integrals. Okay, again this will be a little difficult topic to cover up. Going to be partial fractions and by parts. So yeah, the number of questions asked from these topics are not that many, but there are, at least you can, if you talk about KCET, from these two topics there can be 3 questions. From the partial fraction and by parts, you can have application of these two concepts, and there may be a problem of 2 to 3 from these two concepts only. Again, there will be some concepts of substitutions, but all of that included, 2 questions can be expected from these two particular topics, and they are quite challenging at times. If your concepts are not very much clear, if you have not practiced enough, if you got scared from this topic and moved away from it, then this concept will haunt you forever. That's why I'm here. You have to join right now and solve all the problems that I'm going to explain you today in the session. Again, I have brought some homeworks also for you. I have a very important announcement to make at the end of the session, so please be with me till the end to get to know your homework. I have planned a good amount of questions as homework because this is a very important topic, and this can be only learned by your own practice. I can teach you the concepts, I can help you understand the problems, the how to deal with the concept part of the problem, but you have to do your own practice to have a better understanding of this particular subtopic of the chapter integration. Now, session outline, if you check today, as I already said, we'll discuss 2 topics, starting with partial fractions. Partial fractions will be discussed first. Then we'll dive deep into by parts. They're a very simple topic, but okay, we'll do that as well. Integration by part. Okay, what is this? These are the two of your MOI. What is MOI? Method of integrals. Remember, we had 3. First one was substitution method, number 2 is partial fraction, and number 3 is by parts. So we are completing our MOI today, and in this also I'll discuss somewhere 3 formulas and questions on the 3 formulas of particular functions. Particular functions. Okay, particular functions. Already taught you this, but still I wanted to take some more questions. That's why I've taken over here, and the homework will also will be given on this particular functions. And of course, number 4 is practice of total 15 plus questions in the class itself. So in the session itself, we'll practice 15 plus questions, and later I'm going to give you close to 10 to 12 as homeworks. So if you actually conquer this session, you'll be very much clear with the concept of all the 3: partial fraction, by parts, and particular function. That's why one of the most important session for indefinite integrals. After this, we'll have definite integral as well, but for the indefinite part of the integration, one of the most important session. Starting with, of course, partial fraction. So partial fraction is usually dealt in the case of proper fractions. We know that, right? We have learnt in our, I don't know, 6th, 7th grade, maybe before that, 5th or 6th grade, proper and improper fraction, proper and improper fraction. So similar concept is here as well. Whenever you have degree of the numerator, if I have the fraction written like this in the function format, fx by gx, if degree of the numerator is more than the denominator, you call this to be improper. Degree of fx is more than the denominator function is called as improper fraction. Improper fraction. You don't apply the partial fraction concept for improper fraction. Only in the case of, this is applied only for the case of proper fraction. Okay, for proper fraction. Usually you'll never come across a question in examination. If you see your PYQs, you'll never see that they have given an improper fraction. You're supposed to convert and then move on to the partial fraction part. Never happens. But if it happens, keep in mind that partial fraction is applied only for proper fractions. Okay, so this is a proper fraction, fx by gx, because degree of fx is less than degree of gx. Only in this case you will apply, this is called as proper rational functions, or fraction, the fractional part. So partial fraction concept will apply only to the proper rational functions. Other than that case, you have to convert, divide actually, right? You'll get a quotient and the remainder by gx. This will become your required partial fraction. Then proper rational function. Then you're going to use the concept of partial fraction to break this into partial fractions using the concepts of the constants a, b, c, like that. Okay, so understand this. Conclusion of this slide is very simple. Partial fraction is applied to only proper rational function. How do we define proper rational function? Degree of the numerator function degree of the numerator function is less than degree of denominator function. That's what the conclusion of this slide was. Now I've taken some samples. Usually actually we get the conditions of these three. We rarely come across the other two, okay, but still forms I've given, class notes you can download, okay. If you're new to the channel, subscribe right away and join the WhatsApp channel. Link for that will be given in the description, okay. So go ahead, check the description out, you'll have the link given there. From there you can join the WhatsApp channel. All the classroom content, what I mean, class notes, any formula sheet, all that will be given in the WhatsApp channel only. And of course you can subscribe right now, because we are doing a lot of things for PU2, for KCET students. If you are joining for the first time for my video, I'm telling you, for all subjects PCMB, we are planning a very good amount of content, a good amount of lectures for you to ace your boards and KCET examination, okay. And there are more surprises coming your way, so you have to know that you have to join the channel right away. Okay, so as I said, the first three are the prominent partial fractions applications. Whenever you have linear by quadratic form in the factors given to you. This is quadratic, right? But the factors are given. This is quadratic with the factors being given to you. Please check x minus a, x minus b. When you have that, simply you're going to write the first constant at a by the first factor and b by second factor. Then compare these two. Compare these two to get the value of a and b. We'll see that with the help of questions. We'll see that. Just some forms to remember. If you have here quadratic and cubic over here, we have three factors over here. We'll go with three constants a, b, c. All right. If you have a quadratic, okay, you can go like this also. You have only one factor x minus a, but it's a quadratic form. You can go like this: a upon x minus a and b upon x minus a square. Basically, it's very important to note that for a linear function in the denominator or linear factor in the denominator, you will have only one constant. But if it is non-factorizable quadratic factor, for example this, let's say you cannot factorize this, x square plus bx plus c. You cannot factorize it. You will take this in the linear form then. What did I say? When you have only one factor, okay, linear forms going on like this, you can take single constants a, b, c like this. What about this, sir? This linear only, because you check x minus a square is the quadratic form. For that we'll need two constants, so constant a and constant b. But in this case you check x square plus bx plus c. It's a quadratic, but we can't factorize it. Then we have to use again two constants. So we have taken here as bx plus c. If we could have factorized it, we could have taken b by one factor plus c by another factor in this format. Please check. But we cannot factorize it over here. That's why we have taken linear form as the constant bx plus c. Clear? So I can remove the markings that is done on the screen right now, so that it is very easy to understand once you download the class notes. Okay, next up we have question number 1. Whatever is taught right now, only that much? Yes, only that much. Rest all we will learn with the help of problems. It's mathematics. Better to apply the concepts and learn from it rather than going through the concepts itself, okay? Because this makes more sense to us. We can relate it better if the problems are solved in front of us. Won't you all agree? Yes. Superb. So we have a, what is this? It's a proper rational function. Please check. Degree is not here, like basically 0. Here we have degree as 2. Okay. They've already given this format to us. They have given the partial fraction form to us. They're asking us value of a plus b. Do it. What are you going to do? Take LCM. So you'll have a times of y plus 4, b times of y plus 1, y plus 1, y plus 4, the LCM. Here also 3 upon y plus 1 and y plus 4 and y plus 4. Now compare this numerator from here to here. Compare the numerator from here to here, because the denominator is same, because these two are exactly same. It means this two also has to be same. Now you can compare in two ways. One way is identify quadratic linear term and compare the coefficients. Okay. Other way is simply put some values for y and check which of the expression is getting out. For example, if I put y value as minus 1, y value as minus 1, what will happen? This will become 0, right? And what about this? This is simply 3, sir. So now no change on this side. For the LHS side, can we put the value of y? For LHS side, can we put the value of y over here? No, it is simply 3. So write the 3 over here, LHS side. In the a times of minus 1 plus 4, minus 1 plus 4. What about b plus b times of 0? Because we have minus 1 plus 1 is 0. Okay, so b times of 0. So this is gone. This whole thing is 0. Over here I get 3 equals to, excuse me, 3a equal to 3, right? Made a mistake. Yeah, 1 second guys. Okay, corrected now. We have 3 equals to plus 3a. From here I'm getting the value of a as 1. Compare it. Divide 3 on this side, you get value of a as 1. Same fashion, in this case, put the value of y as minus 4 to get rid of the constant a. Y equals to minus 4, you're going to put 3 will be equal to, please check from here, LHS. 3 equals to a times of 0, and over here plus b times of, we have taken minus 4. So minus 4 plus 1, this is 3 equals to 0, and we have minus 3b. Okay, cancel this 2. I get 1 equals to minus b. It means b equals to minus 1. It means b equals to minus 1. What are they asking? A plus b. Answer is 0. 1 minus 1. Sorry. 1 minus 1, right? Answer is 0. This is your answer, okay? This is your answer. Cross check. This is a very simple question. Simplest form for partial fractions. Simplest question can, I don't think a question like this can come, but yeah, this is the simplest kind of example for the partial fraction. This is very much clear. Let's move on then. Question number 2. As I said, I've taken 15 plus questions I'll discuss today, and of course I have 10 plus homeworks also for you. Very important session, right? All right. But I'll also give you answers for that, don't worry. It's not like I want you to attempt first, then of course I'll give you answers in the video format. Will that work? Super. Same thing. In this case, they have not given the form. We have to decide. How can we decide? Please check. Linear factors, linear by quadratic. Okay, we can apply its proper form. Second thing is, it's factorized. Okay, simple. X plus 1 upon this x plus 2 times x plus 3 equals to what? So, two factors, two constants. So, a upon x plus 2 and b upon x plus 3. Two factors, two constants. Superb. Check this out. A upon x plus 3 plus b upon x plus 2 divided by the LCM, sir. This remains as it is, sir. We have x plus 2 and x plus 3. This much is clear. Okay, this much is clear. No problem over here. No confusion over here. What's the next step? Simply put the value of x as minus 3 to make this 0 and x value as minus 2 to make this 0. You'll get two different values of a and b. Check this out. Okay. So we're going to put one time x value as minus 3. This becomes 0. What about this side? LHS side will become minus 3 plus 1. Minus 3 plus 1 is the LHS side. From here, x value is minus 3, right? I'm putting x value as minus 3. So it will become minus 3 plus 1, LHS side. What about this? A times of 0, because minus 3 plus 3 is 0. What about this? It will become b times of minus 3 plus 2 is minus 1. So we get minus 2 equals to minus b. So I get b equals to 2. B equals to 2. Superb. Same way, I can go x equals to minus 2 as well, right? X equals to minus 2. And if I do that, LHS will become from here minus 2 plus 1 equals to a times of minus 2 plus 3 and b times of 0. I get here minus 1 equals to a. Minus 2 plus 3 is 1. So I get a value is minus 1. Now I have the constant value a and b. Next step is to what? Write this into this format. Write this into this format. Okay. So I have integration a. What is a value? Minus 1. So minus 1 upon x plus 2 dx. First one. Second integration. One more time. There is an integral over here. B. B value is 2. 2 upon x plus 3 dx. Integrate now. I'm getting here minus ln x plus 2 plus 2 times of ln x plus 3. Of course, you'll have plus c over here. That's my final answer. Minus ln x plus 2 and 2 times of ln x plus 3. Okay, that's my final answer. Have a look, guys. Question number 2 is over. Please cross check if I have made any mistake in the steps. You can let me know step number this, because I might make a mistake. Okay, but I think this is right. Okay, question number 2 is done. Let's move on to question number 3 now. Simple enough. Okay. Find x square upon x square plus 4. So this I'm not going to solve it actually. I'll give you a hint to do it. Now for this question there might be different ways. You can substitute, you can do something other than that. But the simplest will be change the variable. What I am going to use is change the variable. You see how it is, how easy it becomes. X square equals to, let's say I'm using it here as t. Sir, derivative. I'm not asking you to do what? I'm not asking you to change the integration. No. I'm asking you to simply, for the partial fractions, change the variable. That much you can do, right? Please check. This whole thing will become what? X square equals to t means this thing becomes x square upon x square plus 4, x square plus 9. This whole thing becomes t upon t plus 4 and t plus 9. That's my partial fraction. Okay. What about now? I can write this as t upon t plus 4 into t plus 9 equals to a upon t plus 4 plus b upon t plus 9. So I get over here a times of t plus 9 plus b times of t plus 4. Same thing repeats over here as well, and this is t divided by same thing. Why I'm not writing this? Because it's the same thing, right? This all is same, t plus 4 and t plus 9, t plus 4 and t plus 9. Okay. Next step is to simplify using t value as minus 9 and minus 4. Let's try that. I want to get one of these over here only. T value as, putting t value as minus 4, let's say. What I get this equals to minus 4 as t times of minus 4 plus 9, 5. And this is 0. This is a actually. Minus 4 plus 9 is 5. This is 0. So I get a value is minus 4 by 5. I get the value of a as minus 4 by 5. Superb. First one is done. Second one. Put t value as minus 9 in this case. Minus 9. Please check. Putting t value as minus 9, I'll have here minus 9 equals to, what I get? I get a times of 0 basically, and we have minus 9 plus 4, right? So I get minus 5. Yeah. I have b times of minus 5. So I get b value as 9 by 5. Have a look. B value as 9 by 5. Because this is minus 5, there is a minus 9. It becomes 9 by 5. Close. B value is 9 by 5. A is known, B is known. You can simply write the fractions now, right? This thing will become what? Have a look. This thing becomes x square upon x square plus 4 is there, right? I can write here this whole thing as, excuse me, last step, carefully, be careful, x square upon, I have x square plus 4 times of x square plus 9. I'm writing this, please check what I'm writing this as. I'm writing this as using a and b. I'm writing this as this format from here. A upon, what is a value? A value is minus 4 by 5, so minus 4 by 5. Okay, and we have integration of 1 upon this fraction, what is it? T by 4. So x square plus 4, okay, with dx plus sign. B is what? This part, 9 by 5. So right here, 9 by 5 integration of 1 upon t plus 9. What is t? X square. So x square plus 9 dx. So no change in the variables dx, dt, nothing. Okay, the t is only used to make the partial fraction easier. All right. Once I get this part, this is integration, right? This is integration of tan inverse 1 by 2 tan inverse of x by 2. 1 by 2 tan inverse of, please check, x by 9 minus 4 by 5, 1 by 2 tan inverse of x by 2, and over here plus 9 by 5 into 1 by 2 tan inverse of x by 3. Sorry, 1 by 3, right? This is 3 square, no? This is 2 square, this is 3 square. X square plus a square, right? Tan inverse formula. X square plus a square. Here in this case a is 3, in this case a is 2. Please be careful. I get here this is cancelled and this is also cancelled. Final answer, I can write over here what I have, minus 2 by 5, minus 2 by 5 tan inverse of x by 2, tan inverse of x by 2 plus 3 by 5, right? 3 by 5 tan inverse of x by 3. Of course, plus c is there. That's the final answer, okay? comes from here. Please check. Minus 2 by 5. I hope this is visible. Minus 2 by 5 tan inverse of x by 2. 3 by 5 tan inverse of x by 3. This is x, okay? That's the final answer. Guys, please cross check. Okay, I don't think it's visible properly. I'll just make some changes. Okay. This is x by 3, okay? X by 2 and x by 3 plus c. This is the constant plus c of integration that we get in the case of indefinite integrals. Superb. Minus 2 by 5 tan inverse of x by 2. 3 by 5 tan inverse of x by 3 plus c. Simple. Question number 4 now. This is clear? Clear, sir. 2 cos x upon 1 minus sin x 1 plus sin square x. Of course, this is a substitution question first. The thing is, you have to decide what you want to do first. Whether it'll be easier for me to go with the partial fraction or substitution right now. I can see clearly in this case, substitution works better. Because if I do sin x as t, cos x dx will become dt. Right? That is easier for me. I'll do that. So I'll take here sin x as t. So I get, please check dt by dx as cos x. From here I get dt equals to cos x dx. Substitute over here, I get 2 is a constant outside. Cos x dx becomes dt, and we have 1 minus t, and we have 1 plus t square. You can apply partial fraction to this. Of course, have a look. 2 is a constant outside. I'm gonna go with this only. 1 minus t and 1 plus t square is my constant. I'll get here 1 as a upon 1 minus t, first fraction, and second will be b t plus c upon 1 plus t square. 1 plus t square. Remember, we cannot factorize 1 plus t square, can we? We cannot factorize 1 plus t square. So I have to go with the form of linear in the numerator. I have to go with the form of linear form in the numerator. Okay, bt plus c. This is what? This is 1 minus t actually. Okay, let's simplify this. I have a times of 1 plus t square plus b times of sorry, not b, right? Not b. I have bt plus c times of. Excuse me. Some patience, guys. Okay, there will be bt plus c here. Bt plus c times of this 1 minus t. 1 minus t divided by 1 minus t and 1 plus t square. Okay. Next from here is the comparisons. From here is the comparisons. Have a look. We have, because if you want, can you put this as minus 1? You cannot do that, right? You have to compare the coefficients in this case. You have to compare the coefficient in the case. So if you check this carefully, for t square term, I'm checking for, first thing is for t square terms. What's the coefficient? For t square. Have a look. Here what I have, LHS side 0, because only a constant is there. It means it has to be 0 t square. If we have only constant, means it has to be 0 t square. So I have the coefficient as 0 for t square. Right hand side, I have a. I have a into t square means I have a. Okay. What about this? I have bt into t square. I have bt into t square. Please check. Sorry, bt into minus t. bt into minus t will become minus bt square. So I have minus b. I'll repeat this step very carefully. For t square, LHS side has coefficient as 0, because 0 into t square will be 0. For the RHS side, we have a t square and minus bt square. So I have a minus b as my coefficient of t square. What I'm getting? I'm getting 0 equals to a minus b. Basically, a equals to b. One relation is clear. Now let's check again. Let's check now for, we can check for constant. Let's check for constant now. We have 2 over here. I'm checking for constant. Constant. Okay. First one is done. Second one is for constant. Okay. Constant is on the LHS side is 2. Constant on LHS side is 2. Please check 2. Okay. What about the RHS side? I get a into 1. A is a constant, 1 is a constant. So a into 1 is a. Next one. We get c into bt can never be constant, right? Because bt into 1 is bt and bt into minus t is bt square. So you don't have a constant term on that. But c with t will be ct, but c with 1 will be plus c. That is also a constant. So I'm getting a plus c is 2. I'm getting a plus c is 2. Please check. A into 1 is a, it's a constant, and c into 1 is c, which is another constant. Okay, so a plus c is 2. Third one. comparing the t term, comparing what? T term, okay, means linear term now. Here what is the linear term for value? LHS side 0, because there is only one constant 2. So LHS is 0, LHS is 0. Check here linear term. Any linear term over here? No. A into 1 is constant, A into t square is quadratic. What about this bt into 1? Yes, bt will be there. It means plus b is there. Check. bt into 1 is bt. That's a linear term? Yes. B is a constant, t is a variable. So linear term. Next what? C into minus t will become minus ct, another linear term. So right here minus c. Correct. Now that's how we're going to write. No? B minus c times of t. This is a linear term. But t is what? This is like 0 into t, right? Is there a t term on this side? There is no t term. 0 into t. Simply what we are getting from here? B minus c equal to 0. So b equals to c. Check carefully. A equal to b, b equal to c. It means that A equal to b equal to c. A equal to b and b equal to c means A equal to b equal to c. Superb. Superb. Now check. A plus c is 2 and A equals to c. It means that A equal to b equal to c equal to 1. It means that A equal to b equal to c equal to 1. Okay. Now the integration is transformed. What's the integration given to us? It was given as 2 cos x upon 1 plus sin x, I think, or 1 minus sin x. 1 minus sin x actually, and 1 plus sin square x with dx. This was minus. This was minus. All right. And what we are getting? We are going to use this one, right? That's the transformation, right? Please check. That's the transformation in the partial fraction. So a upon 1 minus t. So 1 upon 1 minus t dx. Sorry, dt. My bad. dt. Excuse me. Mistake. Next was what? Next was b into, so 1 into t plus 1 divided by what? 1 plus t square was there, if you remember. We have again dt over here. Check. 1 into t, because b value is 1. 1 into t plus 1. So t plus 1 by 1 plus t square dt. This is what? ln 1 minus t, but there's a t coefficient is minus 1. The coefficient of t is minus 1. I told you this, divide by same value, which is minus 1. You cannot have that. If it is ln of 1 plus ax, divide by a. In this case, a value is minus 1, that's why dividing by minus 1. Moving on. I can have over here t plus 1, right? So let's do one thing. Right here, t upon 1 plus t square as one of the integral, and next one will be 1 upon 1 plus t square. So we have separated two different integrals over here, t upon this thing and 1 upon this thing. We have t plus 1, right? So t upon this and 1 upon this. Okay. This will be becoming minus ln 1 minus t. What about this? What about this? Let's continue with this only. I get, if I take this as t square as, if I take 1 plus t square as, let's say, variable y, derivative will be what? Derivative will be 2t dt equals to dy. It means t dt will be what? dy by 2. Okay. So I can write this as dy by 2. So 1 by 2, and over here you'll have what? Simply y plus formula for this, tan inverse of t plus c, constant is there. Okay. Check. Now this is going to be what? I have minus ln 1 minus t plus 1 by 2 ln y plus tan inverse of t plus c. Okay, but this all cannot be right because we have the variables t, y and t. We should have everything in terms of x only. First thing was t equal to sin x, another thing was y equal to 1 plus t square. What does that mean? 1 plus sine square of x. So y is 1 plus sine square of x and t is, what is it? T is sine x. Substitute in this thing, you have the answer. That's the final answer in that case. Minus ln 1 minus sine x plus 1 by 2 ln 1 plus sine square x plus tan inverse of sine x. Superb question. Not difficult, but flow is there. Okay. Use application of substitution method also with the partial fractions. Have a look. All this should be clear. Done. Okay, so I've done 4 questions so far in the partial fractions. I hope this is very much clear. Okay, next. So I'm trying, okay, sometime it might look messy, but if you follow my steps properly, my words, I think they'll be clear, right? Question number 5. Now this is the homework. So 4 questions I've done, 2 you have to do. Homework is this. All right. How are you going to solve this? Please think. 2x plus 7, I'll give you a hint. 2x plus 7 upon x minus 4, the whole square is there. You go like this. A upon x minus 4 plus b upon x minus 4, the whole square. Factorize, get the value of a and b, you have the answer. I think option should be either C, I think. Please check. I'm thinking that option should be C. Cross check. Let me know in the comment section, is option C right or not? Comment your answer. Is C correct? Let me know. Is C correct? Okay, how to do it? In this format I've given you. Question number 6 now. Evaluate this same condition. You'll have 4 variables over here, sorry, 4 constant over here, a, b, c, d, 3 because of this and 1 because of this. So you'll have x square upon this thing equals to a upon x minus 1 plus b upon x minus 1 the square plus c upon x minus 1 the cube plus t upon x plus 1. So you'll have 4 of the constants. This is 1, okay? This is 1. X minus 1 the square and x minus 1 the cube and plus x plus 1. So you'll have the again 4 of the options. This is C, right? Please check. I think the answer should be D over here. Not sure, but you check. Okay, again, homework. This is your homework. Comment your answer. Comment, answer, and check whether it is D or not. I've given you a hint and I've given you final answer as well. Question number 5, answer is, hint is this, answer is C. Question number 6, hint is this, answer is D. Got it? 2 homeworks. Moving on to our question now. Question number 7. A very beautiful question. You need to pay attention to solve this problem. You have to know the formulas of trigonometric function, and of course there is some calculations also involved. So please be attentive to the screen right now. Very, very important. It's a request. If you don't, then halfway you'll forget how to get the answer. Cos x, sin x. Here, 2 things to notice. I have tan and x by 2. It means I have to use half angle formulas of sin x and cos x. They only get x by 2, right? But I have to use in the form of tan. Why tan? Because everything in terms of tan is there. Tan and cot, tan is tan and cot. It means, think like this. Options are in terms of tan and cot, and angle is half. Okay. Cos of x. Formula is there. 1 minus tan square x by 2 and 1 plus tan square x by 2. Sin x formula is also there. Twice of tan x by 2 and 1 plus tan square x by 2. Okay, let's use this now. What I have, dx as it is, I'm getting over here 1 minus this whole thing. If I use the fraction properly over here itself, I get 1 minus cos of x minus sin of x. Just to simplify, if you add these two, you get 1 minus tan square of x by 2. Then comes a plus sign again, right? Yeah, minus sign, sorry. And we have twice of tan x by 2. We have the same LCM, right? 1 plus tan square x by 2, 1 plus tan square x by 2. We have the same LCM. So I can take it at once only, I think. Yeah. I have the same denominator in both the cases. So this will come over here when I make the equivalent fraction. So basically 1 plus tan square will come over here. Let's see the simplification. I'm going to erase this later, so please pay attention. I'll have this term over here. If you make the equivalent fraction. So I'll have a big fraction on the side, and this will be what? 1 plus tan square x by 2. This term, first term. This will mean I'm going to open this bracket now. I'll have minus 1, and minus of minus will become plus. So plus tan square x by 2. Over here, I get minus 2. So minus 2 tan x by 2. And what is this? This is 1 plus tan square x by 2. Okay. Check. 1 and 1 is cancelled. Okay. So what I'm getting now? I'm getting tan square plus tan square. It will become 2 tan square x by 2. So I'll have 2 tan square x by 2 minus 2 tan x by 2 divided by this bracket 1 plus tan square x by 2. 1 plus tan square x by 2. Okay, messy, right? Okay, just little bit patient with me. Nothing else, simple calculations. Okay, taking LCM, making the fraction denominator as 1 plus tan square x by 2. I'm doing all of this to get the denominator. Okay, that's all. Alright, so far I have 1 plus tan square x by 2 and 2 tan square x by 2 minus tan x by 2. Superb. I can take here 2 common. Sorry, I can take here 2 tan x by 2 common. So I have 2 tan x by 2 common. It becomes tan x by 2 minus 1 divided by 1 plus tan square x by 2. Now I have this. I want to use this only. So I've done all of this. Started from 1 minus cos x minus sin x. From this and this, they are same thing. I've taken this, used these two formulas to get this result. Okay, I'm going to use it over here. Let me write this one step. So all of this is for the simplification of denominator. Hope this is clear. All of this is for the simplification of denominator. So this thing becomes what? This expression. I'll have, of course, dx will be there. I'm writing in the denominator, right? So I have to write this part first, twice of this. So twice of tan of x by 2 times of tan of x by 2 minus 1, and this will go up, right? If you write in the denominator, this will go up. I have here 1 plus tan square x by 2. This much is clear. Have a look. Okay. This part, if you put in the whole thing in the denominator, will go up. Okay. So now I'm going to write this with one substitution. What is that? Substitution is very simple. Tan of x by 2 as t. Tan of x by 2 as t. So derivative will also be there. We'll do it over here. Please check. Tan of x by 2 as t I have taken. Let me do this. I get x by 2 as tan inverse of t. So I get x as twice of tan inverse of t. No problem over here. Now I'm going to take the derivative. Check this out. It will become 1. It will become twice of 1 upon 1 plus t square. That's my derivative, dt by dx actually. I get dx over here. So dx equals to twice of 1 plus t square dt. Dx equals to twice of 1 plus t square dt. Now check the integration. I had dx over here, right? I had dx over here. That I can write this as, I was having dx over here. I had 1 plus tan square x by 2, and over here I had twice of tan x by 2 times of tan x by 2 minus 1. Right? Tan x by 2 minus 1. Cross check. Same thing I've written over here. The same expression I've written there. Alright. Now, this step of using the substitution, right? I get what? 1 plus t square. 1 plus t square the numerator. This part 2t times of t minus 1. 2t times of t minus 1. Superb. Over here dx, this value 2 upon 1 plus t square dt. 1 plus t square dt. This whole thing is cancelled. Okay. Alright, what I'm getting now? This 2 is also cancelled. So I have so far dt upon t times of t minus 1. Okay, separate this. You can apply the condition. You'll have this only 1 upon t minus 1 minus 1 upon t. Okay, yeah, you'll have this only. This is a partial fraction actually. If you apply this, you'll get the partial fraction like this. 1 upon t minus 1 minus 1 upon t. T will go here. You'll have plus t. Yeah, minus t plus 1. Correct. This is right. With dt over here, this whole as the integration. Now, I understand you might be thinking that, sir, how can we do all of this in 1 minute, in 2 minutes? It's not possible. Agreed, it's not possible. Agreed, it is not possible. Then how can you do all of this? First of all, by practice, no dear, by practice, what you see over here, the simplification, this formula should be in your mind. Okay, next all, this should be also done in your mind. So these steps can be done in your mind actually and very faster. Think about it. They are simple calculations, right? So all the steps you see on the screen right now might look lengthier to you, but if you do in your mind, do one thing, try right now. Study from this and try in the mind that you can get it or not. You will be able to. Believe me, you will be able to. Make some, make this question, practice couple of times. When you do that, you can do all these steps in your mind. Think like this, no? Close your eyes. What is this cos x formula? I know, sir. 1 minus tan square by 1 plus tan square. Okay, sir. Don't write x by 2 in your mind. Just write 1 minus tan square, 1 plus tan square. Sin x formula, I know, sir. 2 tan upon 1 plus tan square. If I take LCM, 1 plus tan square is the LCM. That will go in the left hand side because there is a 1 over there. I get minus cos is there. It means minus 1 plus tan will become, right? Minus 1 plus tan will be there. Same, I get minus 2 tan. It means 1 and 1 is cancelled. Right, and so on. If you can simplify like this, basically you have to write this step. In the whole thing you see over here, you need to write only this step. Okay, so you got it right. Only this step has to be written. Rest all is in your mind. This is x by 2. This is x by 2. So might be a little not clearer, but I hope you get it. I hope you get it. Okay, this is all x by 2. Okay, this is square. I know it's not very clear. I understand that part. Your frustration if you are frustrated. But yeah. After this, substitution is there. You know this as well. 1 plus t square and 2t, t minus 1. This part is your partial fraction actually. So yes, this will be a lengthy question. This kind of question comes in your boards. Okay. If you see the objective part, it's not a PYQ, but question like this can come. If you train your mind for this worst case, any question that is easier than this will be easier, right? It's not a PYQ. I'm not saying this question might come, but if you train yourself for this part, if you work hard to get this right in 2 minutes, it means that you have trained so much that some simple question comes, any variety of question comes to you from the integration, you can get it right. Okay. So believe me, you can do all these things in your mind. You can do this process, this whole thing in your mind with practice. That's what. KCET examination, you cannot do all the things in the paper. In your mind, you have to do a lot of steps. That's why I'm not skipping anything. If I skip steps over here, what will happen? You will not be able to relate to that. So read all the steps, but try to do the steps in your mind, dear. Please, it's a request. Okay. So this is correct. Now you can integrate this. You'll have ln of t minus 1 minus ln of t plus c. This becomes what? Ln of t minus 1 by t plus c. What I get? Ln of 1 minus 1 by t, okay, 1 by t plus c, ln of 1 minus 1 by tan x by 2 plus c. What I get? Ln of 1 minus cot x by 2 plus c. Please check. 1 by t means 1 by tan. 1 by tan is cot. What is the option? The option is c, right? Got it? A beautiful question. I hope this was clear. Please let me know you all understood question number 7. Let me know you all understood question number 7. Clear? This is also clear. Guys, yes? Please let me know. I would love to know your comments. If it is difficult, I'll again come back and explain this question one more time. But please let me know in the comment section you understood question number 7. Right? Okay. Now integration by parts. Over here we have only simple 2 formulas. One thing to remember is eyelet. This is the priority order. This is the priority order. Starts from which? I represents ITFs. L represents, of course, log. A is the algebra. Okay. And T is trigonometric. Okay. Excuse me. T is trigonometric. And A is exponential. Is the exponential functions. Okay, whether it is a power x, whatever it is, doesn't matter. That's your order. Okay, exponential function, basically exponential function. Now based upon this, you'll have a preference. You'll have a function 1 and function 2 over here. Basically, whenever you have 2 functions multiplied to each other, how do you solve them? That's the method. So based upon this, you can figure out how to get this. 1 into 2 is there. So step is, first one, this first one, what are you going to do? Keep it as it is. Okay, whatever the first function, keep it as it is. The first function kept as it is. Second function, integration. Now they might tell you the formulas in the book, u dv minus v du. Yes, you do all of that. Okay, you can do all of that, but my method, I stick to this method and I find this is very easy. Why to do dv and all? No problem. Just simply take first and second. You know first and second, right? So what is first and second? First function, second function. How do you choose that? Based upon the preference order, the priority order. What is this called as? This is the priority order. Okay, based upon the priority order, you set your first and second function. All right, sir. Now, which was the first function? Keep that as it is. First function as it is. First function as it is. Repeat. Right out after me. First function as it is. Right now, all of you. First function as it is. Second function, integration. There comes a minus sign. Integration of. Minus sign. Integration of. Derivative of first now. First functions. Derivative. First functions. Derivative. One more time, integration of the second function. This whole thing integration again. Now it might look very complicated to you. Sir, first function derivative, second function integration, you have taken another integration over here. Yes, it is. First function derivative, second function integration, product of that will be a function, right? That integration. Looks complicated, but it is not actually. Only in very, very few questions, this part will be difficult. Otherwise, it will be very, very simple. Okay, so first function as it is, second function integration minus first function derivative, second function's integration, product of those two, and integrate one last time. Integrate the product one last time. Okay, chali. All right, 1 second. This whole thing, the integration. Okay, you can do that. Completely doable. Check this out. If fx is my first function as it is, second function's integration. First function derivative, second function's integration, the entire products again one more time integration. So priority order and what I taught right now. No need to use any of the formulas. Just use this formula. Usually I never say that. I say you can refer whatever you want to. But I'm telling you this is the fastest way to remember the formula. First function as it is. How do you pick the first function? Priority order. Islet. Okay. Islet is the priority order. Once you are done with the first and second function, first as it is, second function integration, minus first derivative, second integration, product, integration one more time. Let's start. First, I've taken 2 questions just to define that. I've taken 2 questions just to, actually, why I've taken these 2 questions? 2 reasons are there. When I give you integration formulas, student ask me, sir, what is the log integration? We'll deal with this over here. So whenever you ask log integration, that is done with the help of by parts. Inverse integration by parts. Okay, of course I have taken these 2 simple integrations by parts to understand the formulas also. Okay, let's begin. All right, okay, just needed to have some more water. The throat was struggling a lot. Log of x plus 1 dx. How do we solve this? Islet first. I-L-A-T-E. L-A is the condition over here. Why L? Log is there. Algebra. Which is algebra? How many functions over here? We have 2 functions. The first function is, of course, log. What's the other function? The other function is 1. Nothing is there, no? X plus 1 is not the function. Do not forget, okay? X plus 1 is the part of log. That's not your second function. Your second function is 1. What is 1, sir? Nothing is multiplied. You're going to take 1 only, right? Okay. So we have log x plus 1 times 1 dx. Okay. When you do that, this becomes your second function. This becomes your first function. Formula is very simple. Keep this as it is. Integrate this one. Integrate 1. Minus sign comes. Integrate. Derivative of this log. I get 1 upon x plus 1. Log derivative is 1 upon x plus 1. Integration of this. One more time integration of 1 dx. This whole thing with the dx. Have a look. I get over here. This will become x, right? So I get x log of x minus sign we have over here. I get x upon, this is nothing but what? 1, right? So x upon x plus 1 dx. X upon x plus 1 dx. Superb. x upon x plus 1 dx, no problem. I get x log of x minus, right here, x plus 1 minus 1 by x plus 1 dx. What I've done, I'm doing this for my second derivative, okay? X plus 1 minus 1. When I do that, I can, actually make a grouping over here. So my final answer is like this: x log x minus, check this out, x plus 1 by x plus 1 dx, and we get plus 1 upon x plus 1 dx. This minus 1 with this minus 1 becomes plus, so you get plus 1 by x plus 1. Answer is x log x, and we have minus, excuse me, just a second, this will cancel, right? So I get only dx left, means minus x plus ln x plus 1 plus c. That's my answer, okay? My answer is x log x minus x log of x plus 1 plus c. Log of x plus 1 plus c. Have a look. Please check. That's your answer for the first part. For the first part. Clear? Let's move on to second part now. Tan inverse of x dx. Okay. So we had part 2 was tan inverse of x dx. Okay. Same thing. 1 into 2. Okay. Sorry. 1 into the function given to you. Tan inverse of x into 1. Rule continues. We have tan inverse of x as it is, integrate 1 dx minus, differentiate tan inverse of x, we get 1 upon 1 plus x square, and integrate this thing will become what? X only, right? Please check. Integration of 1 is what? Is simply x. Alright. I'm getting here x tan inverse of x minus, I have x, right? I have x over here, x upon 1 plus x square dx. Let's do one thing. Substitution we have to use. Take 1 plus x square as t. You get derivative as 2x dx equals to dt. So we get x dx equals to dt by 2. This whole thing becomes what? X tan inverse of x minus 1 by 2 dt upon t. Dt upon t. This whole thing becomes what? X tan inverse of x minus 1 by 2, and I have log of t plus c. So x tan inverse of x minus 1 by 2 log of t is what? 1 plus x square, right here. 1 plus x square plus c. Final answer. Please check. That's my final answer. X tan inverse of x minus 1 by 2 log of 1 plus x square plus c. Since these questions are not used, this formula of tan inverse x is rarely used, that's why we don't learn the integration of tan inverse of x as a standard formula. Okay, we do learn the derivative of tan inverse of x, but we don't learn the integration of tan inverse of x as standard formula, because they are very, as you can see, difficult to remember. They actually become a question. Okay, basically what we did right now is a proof of finding the integration of tan inverse of x. Okay, the derivations actually, but very simple. Clear? Both of them are clear. So both questions has been taken for a sole purpose of understanding the question that comes to your mind. So what is the integration of tan inverse, integration of log? Okay, in the first session when I start the teaching, if you were in the class right now, you would have asked me, sir, what is the integration of log? That's how you do it. Okay, you have to use the by parts, and for tan inverse also. Second is how to apply the by parts condition. Now next question, x sin 3x. Same thing. ILATE, algebra has preference. Algebra has preference over here. Please check. A is before t. So you're going to keep x as it is. Integrate sin 3x. Minus sign will come. We have a dx, of course. And we'll have minus sign. Differentiate x, you'll get 1. Derivative of x is 1. Integrate sin 3x with dx. Okay. We have one more time. Dx. Alright. So we get here x, sin integration is what? Minus cos 3x divided by 3, because 3 is multiplied to the x, the variable. Minus sign is there. Integration of this thing. Same thing, we get minus cos 3x divided by 3 dx. This minus comes out, becomes plus. So we have minus x cos 3x by 3, and we have plus integration of cos 3x by 3 dx. Okay, this is cos only. What I get? Minus x cos 3x by 3. This will become what? Integration of cos. It will be sine. So we'll have sine 3x. We also have 3 over here. One more 3 will come plus c. My final answer is minus x cos 3x by 3 plus sine 3x by 9 plus c. Have a look. 9th is done. Question number 9 solved, guys. Simple. Application of by parts, algebra and trigonometric functions are involved. Had fun. Okay. Question number 10 now. Application of by parts as well as substitution. Have a look. Sin 2x. E sin x. What is sin 2x? 2 sin x cos x dx. Substitution will be sin x equals to t. How come so? Because we have cos x ds as my derivative. Please check. I get cos x dx equals to dt. Over here what we get? We get 2 is a constant, keep it outside. 2 e power t times t, and this whole thing is dt. Correct? E power sin x is e power t. Sin x is going to become t, and we have cos x dx as dt. 2 comes out as the constant. Superb. I let again by parts. You can see algebra is t and exponential is the last one. So I have the e power t as no preference. Okay, t is given the preference. So keep t as it is. Integrate e power t, which will be e power t only minus sign. Differentiate t, you're gonna get 1, and integrate e power t one more time. We have to do with dt as well. Please check. You're getting twice of t et minus integration of et again. We'll have et plus c. Take 2 times of e power t common. I get t minus 1 plus c. Please check. Integration of this et will be again et. Okay, this is et. You can take e power t common, get t minus 1. Now put the value of t back in. 2 times of e power sin x minus 1 plus c. Final answer. This question has application of both what? Substitution as well as by parts. Loved it? Okay. Now simple questions we have solved enough. Let's go and solve some difficult ones on the basis of some particular functions. More type of particular functions. Right? I've already taught you all of this. Square of a square minus x square, the integration. Sorry, square root of a square minus x square, the integration will be having sine inverse in it. X by 2, the same root repeats. A square by 2 sine inverse of x by a plus c. If you have plus sign, this will become same root with x by 2. This will be a log. If you have minus sign x square minus a square, you'll have a minus sign over here, and this will be the same root with the log. Okay. I've taught you all of this, how to crack this, how to understand these formulas. Remember signs also, when you have plus over here, this is plus. Only minus will be in the case of x square minus a square. Yeah. I've given you all these formulas. Now application of these formulas. Okay. Integrate this x square minus 3x plus 1 upon root of 1 minus x square. It's a very, very good question. You'll see. So right now, you can see we have 1 minus x square over here. We have x square plus 1. I have to change some grouping over here. Good question. Be patient. It's a very good question. So be patient. Be with me till the end. You'll enjoy the question for sure. Okay. Let's start. I'm going to take the minus sign common. It becomes what? It becomes minus sign minus x square plus 3x minus 1 divided by root of 1 minus x square. Superb. Now I want 1 minus, right? So I'll get minus sign over here. I'll write 1 minus x square. I've taken this 1 extra. Remove that as well. Correct. This 1 and this 1 will become what? 0. Right? So no change. But I needed the 1 minus x square. I needed the 1 minus x square. So I've added 1 and removed that 1. Superb. Check this out now. So this whole thing becomes now 1 minus x square plus 3x minus 2. Group it like this. Divided by 1 minus x square. Apply the integration with dx. Apply the integration with dx. One of the group will be this. So it will be what? Minus sign integration of 1 minus x square divided by root of 1 minus x square with dx. One group is defined. Next group we'll have over here minus 3x upon root of 1 minus x square. Other one, there's a minus 2 over here, it becomes plus 2 because of this minus sign. There's a minus outside, okay? It'll become plus 2. So plus 2 upon, integration is there, 1 upon root of 1 minus x square dx. I've separated this terms over here. Also there's an integration like this. Got 3 terms. Please pay attention. Fun question, very, very much fun. Have a look. Start from here. This will cancel, right? I'll have only this left, 1 minus x square dx. This is clear? Root and the whole. Only root is left? Okay. What about this? If I make some change over here, one second guys. If I make some change over here, write this as, let's say 1 by 2. 1 by 2. What I get? And write this 3 also outside. Okay. This 3 over here. And this inside the root, inside the integration, I write this as 2x dx. Please check. What I'm getting? I'm getting again one more time. This. Okay. And this is what? This is a formula, right? Twice of sine inverse of x plus c. Okay. Just the middle term is your everything. Pay attention to this part. I'm writing this as, actually, pay attention. 3 I've taken outside. I'm going to take this minus sign inside. This minus 2 I have taken inside. Why? Because if I take 1 minus x square as t, it will become what? Minus 2x dx will be dt. Think. This is what? This is actually dt upon root t. Right? Please check. If I take 1 minus x square as t, write that down right now in your notebook. 1 minus x square as t, then minus 2x dx is dt. This is dt. I made that change over here. Okay. So what I get the integration for this? It'll become root t by 1 by 2. It'll become root t by 1 by 2. If you integrate this part, what you get? You get root t by 1 by 2. Correct or not? And what do you have over here? 3 by 2. 2 and 2 cancels. So what is this going to become? 3 root t. If you integrate this, it'll become 3 root t. What is root t? 1 minus x square. This whole thing will become what? Please check. This whole thing will become what? Plus 3 root 1 minus x square after the integration. Not before, after the integration. This is the answer. 3 root 1 minus x square. And of course, this is as it is. 2 sine inverse of x plus c. I can erase this part now. Can I erase this? This form I can erase. I can erase this, right? I hope all of you got it, how I've got that result. Okay. Just a second. This was what? It was plus 3 root of 1 minus x square. This two term is done. What about this? That's a formula, right? That's a formula. This becomes what? X by 2, this whole thing. X by 2, same root repeats, 1 minus x square. And we have over here plus a square by 2. What is a square? 1 in this case. So 1 by 2 sine inverse of x by a. Sine inverse of x. Correct? So we have sine inverse over here, plus 2 minus 1 by 2. Plus 2 minus 1 by 2. It will become what? 2 minus half is minus 1 is plus 1.5. So please check. Final answer. Here we have 2 sine inverse. Here we have minus 1 by 2. It will become 3 by 2 sine inverse of x. This one term is done. This root is common. Take root common. 1 minus x square is the root common, right? 1 second, guys. Okay. 1 minus x square is the root common. Yeah. What is left over here? This term has 3 in it, and this term has minus x by 2. And that is all. That's my final answer. Please cross check. I have used this formula. In this particular question, the first part I have used that formula. Have a look. This 3, if I take this common, right? If I take 1 minus x square common, I get 3 over here, first term. Over here I have x by 2 with a minus sign. So minus x by 2. Okay. And for this I have minus 1 by 2 sine inverse of x. I have plus 2 sine inverse of x. It becomes what? It becomes plus 3 by 2 sine inverse of x. Answer is this only. Superb question. Beautifully done. I hope you got it. I hope all of you got it. 11th one is clear, right? Guys, 11th one is clear. Have a look one more time. Clear all of this? Question number 12 now. Question number 12. Another very beautiful question. Again, this is a KCET ready problem. Okay, this is a, so the thing is, integration is a difficult chapter. I understand that. And of course, this is a KCET. So this will be difficult, okay? But with practice, you can deal with it. How can you deal with it? You get to learn how to, write steps in your mind. If you can do that, your job is done. This problem. Super. Check this out. We have some substitutions over here as well. 1 plus e power x as t square. Why t square? Because we have root in a. We have root over here. Okay? Super. Differentiate this. Differentiate this. You'll get e power x dx equals to 2t dt. E power x dx equals to 2t dt. Correct now? Derivative of 2 square is 2t and dt by dx will be there. Dx comes on this side. Super. Next what? This one more step. Next what? Alright, x value from here. You get e power x equals to t square minus 1. I want to find x value, so apply log on both sides. I get x equals to ln of t square minus 1. Log of t square minus 1. That's the value of x. Because I have x over here in the numerator. Now the question you check. This question becomes, what is it? This question is, please check, ln t square minus 1, okay, that's the x value, divided by root t, sorry, not root t, my bad, not root t, it becomes t, right? It becomes t then, t, and we have 2 outside and we have dt over here. We have 2 outside and dt over here, correct? Please check. 1 plus t square, this is simply, this whole thing is dt, this ex dx is dt, 2 dt, so I get 2t dt. Sorry, there's a t also over here, my bad. 2t dt. So we get 2 outside, t here, this t and this t is cancelled. What is the question now? Twice of ln t square minus 1 dt. Integration of log, we have to use by parts. Do it. Use by parts. 2 is a constant outside, keep it outside. Log will be kept as it is, so keep log of t square as it is. I'm using by parts, guys. I'm using by parts. Log of t square as it is. Okay. Integration of nothing is there means 1 is there. Nothing is there means 1 is there. So integrate 1. Integrate 1 with dt, minus sign will be there. We have a integration again. Derivative of this will be what? 1 upon t square minus 1 with twice of t. We'll again have this part. We'll have 1 dt integration, this whole thing with 1 more time dt. Please have a look. Okay, this is all by parts. Okay, this 2 is outside this whole thing. I get ln t square minus 1. Okay, this is going to be what? T. So right here, t outside. One second. I need some space over here. I'm gonna write 2 outside. This will become t, right? This will become t. So right here, t ln t square minus 1. This is a minus sign. What we get again, this is going to be t. So I'm getting over here, minus sign is there. I have 2t square. I have 2t square upon t square minus 1 dt. Do one thing, bring this 2 outside. Bring this 2 outside. So write this 2 over here and write this as t square. Write this as t square. Okay. I've taken the 2, the constant 2 outside. It becomes t square upon t square minus 1. This 2 is over here. Okay. This 2 is over here. Now for this part, I have to use one more time. Some minus 1 plus 1. Minus 1 plus 1. Because it will become t square minus 1, t square minus 1, right? That's why. Have a look. So I'm getting what? This whole thing becomes one more time. Yeah. Minus 2 is outside. Okay, is it minus 2? No, it's plus 2 only. There's no minus 2. Plus 2 is outside. T is there. ln of t square minus 1 is there. And if I separate these terms, I get minus 2 is a constant. This will become what? I am separating over here t square minus 1 and plus 1. It will become simply integration of 1 dt. There will be another minus sign with 2. Integration of 1 upon t square minus 1 dt. T square minus 1 dt. Please check. t square minus 1 dt. Okay, have a look. There's a particular function I'm going to use over here, so you have to be very, very careful what formula is coming. Now this is t square, okay, and this is 1 square. 1 means 1 square. X square minus a square. X square minus a square. Check this out. So I get over here, this is as it is. I can see this is again giving me t, right? Giving me t again, and this 2 is outside for every single term. I hope you get it. This 2 outside is for every single term. This 2 is outside for every single term. So let's do one thing, bring this 2 back in, and I take this is going to be t, right? I take this t common. So I get t common. Alright, what I have, this 2 goes in, I get twice of ln t square minus 1, and I get this will become minus 4, and what will this be? Minus 2 times of ln, again log t minus 1 upon t plus 1 plus c. This is it. Now from here you have to just see the approach. Please check this out. This is nothing but your this term ax plus b, because ln of t square minus 1 is what? That is nothing but your value of x. X is ln of t square minus 1. This will become 2x minus 4. Please check. This is your 2x minus 4. X is ln of t square minus 1. Okay, x is ln of t square minus 1. So this becomes t. What is t value? T is what? Root of 1 plus ex. T is root of 1 plus ex, which is given over here. This is my t. Please check. So 2x minus 4 I'm getting means a value is 2. So far I'm getting a value is 2. B value is minus 4. B value is minus 4. What about this term c? Have a look. We have t minus 1 over here. We have t minus 1 and t plus 1. But I want plus in the numerator, minus in the denominator. We have minus over here, plus over here. But I want plus by minus. It means I have to take a minus sign over here. I need to reciprocate this. I need to reciprocate this. So it will become plus actually. If you reciprocate, if you write here plus 1 and write this as minus 1, this will become plus sign. Please check. In the beginning it was minus by plus, but I want plus by minus. I want plus by minus, okay? Because I have plus by minus in the form. So this will become minus, it will become plus 2. So I'm getting the c value. Compare here 2 and this c. I'm getting the c value as 2. 2 plus 2 is 4, minus 4 is 0. Answer is D. Got it? Got it? So difficult. I understand that. It is difficult actually. Not very simple, but yeah. Question is there. Okay. Let me know how many of you got it right. Or let me know how many of you understood this particular question. Number 12. So flow was very simple. They're asking us a plus b plus c. I didn't confuse right now because they have already given the integration. Okay, if you can get the answer directly, if you can actually understand this, that this is coming, you don't have to do the entire integration. Please check, this is going to be t, so this t is there. It means one of the constant is t, so a value is 2. This is going to be your x value, this is x. So if you do minus 2 into another 2 will come over here. From this case, this outside, it will become minus 4. Answer will come from here only. This plus 2 into this minus 2 becomes plus 4, minus 4, that is there. Over here we have another constant minus 2, log is there, right? T square minus 1. I get t minus 1 upon t plus 1. But I want t plus 1 by t minus 1. This is t. I get the answer as plus 2. Answer is option number D, which is 0. Have a look. All this is clear. Next is question number 13. Integrate with respect to x, x minus 5, 7 minus x. First step is as simple. Expand it. What do you get? You get minus x square. You get minus 35. And you get 7x plus 5x, so 12x minus 35. Okay, I want to make a whole square. Have a look. So write this constant over here, minus 35 over here, and I'm getting this as minus sign common, x square minus 12x. That is okay. I'm rewriting it just to make a whole square because x square has to be positive in that case. Alright, why whole square? Because the particular function formula always have x square. I always have x square in it. Have a look. So I can make it 35 minus, I have x square, I have minus 2 times of x. The number is 6 over here. The number is 6 over here. Please check. 2 into x into 6 is 12x. It means b value is 6. So add here 6 square and remove here 6 square again. Minus 35 minus x minus 6 the whole square. And if you remove this minus and minus 6 square, this will become plus 36. Right? The first 3 terms over here becomes x minus 6 the whole square, and this minus 6 square becomes plus 36. Super. This you combine with this. I have 1 minus x minus 6 the whole square. 36 minus 35 is 1. Formula is a square minus x square. Answer you all know. Integrate this. Integration of root of 1 minus x minus 6 the whole square dx. Right? This becomes what? X minus 6 by 2. Same root will repeat. So I get x minus 5 into 7 minus x. Same root that is given over here. And we have plus a square by 2. So 1 by 2 sine inverse of x minus 6 by 1. Of course plus c is there. Of course plus c is there. Have a look. Correct now? X minus 6, this whole thing by 2. Same root repeats. This whole thing is coming from here only, no? Plus 1 by 2, because a square by 2, a is 1 over here. So 1 square is 1, 1 by 2. Sine inverse of x by a. This x is entire thing. X minus 6 by a, which is 1. Answer is this itself. That's my final answer. X minus 6 by 2 root of x minus 5 into 7 minus x plus 1 by 2 sine inverse of x minus 6 by 1 plus c. Done. Question is over. 14th now. Integrate with respect to x times of root of 1 plus x upon 1 minus x. How do you solve this question? I'll not give you all the steps, but I'll give you the key steps to get this answer. You have to let me know whether you got it right or not. Okay? So keep x as it is. Now factorize this. Basically rationalize this. You get 1 plus x, rationalizing it. I get over here 1 square minus x square. Okay? Correct now? I'm multiplying this with 1 plus x, 1 plus x. So I get 1 plus x the whole square in the numerator. This becomes 1 minus x square. Okay, 1 square minus x square. I have x times of 1 plus x divided by 1 minus x square in the root. Because you have 2 means the root will be cancelled, right, in the numerator. Super. From here I'm getting what? X square plus x upon 1 minus x square, right? 1 minus x square. Alright. What I get for this? I get here x square upon root of 1 minus x square plus x upon root of 1 minus x square. Alright. I can write this as minus sine x square, minus x square divided by root of 1 minus x square plus x upon root of 1 minus x square. Excuse me. This is minus sign over here, okay? This minus sign is outside. Next step. So I want the same format. So I'm going to add 1. So it will become 1 minus x square minus 1 divided by root of 1 minus x square. There's a minus sign outside as well. And this is very simple. X upon root of 1 minus x square. Okay? Over here, this will become what? Minus sign. Separate this. Root of 1 minus x square. Okay? This will become minus 1. So it will become plus actually 1 minus x square. And we have x upon root of 1 minus x square. We have integration everywhere. Integration with dx all the time. This is with the dx as well. Dx and dx. Okay? Dx. This you know, particular function a square minus x square. Use that over here. What about this? Sine inverse of x. That's the formula. This is sine inverse of x. This is particular function. Right? And for this part, you have to multiply minus 2 over here and minus 2 over here. Multiply this as minus 2 and divide by minus 2. Okay? You'll get the same thing. This will become log of 1 minus x square. Okay? Yeah, this will become root of actually 1 minus x square. Have a look. Got it? Yeah. So try this also. Solve it. This is the method of substitution. So I've given for all the different steps. This is going to be particular function. Sine inverse of x. This is substitution method. Apply and solve it. Question number 14 is over. Okay, I've done a lot of questions now. You can solve this problem, these simple steps. Last step you can solve. Okay, 15th question number 15. This one also is a homework. You don't have to solve all the steps, because see, think first of all, try to think what is the perfect square over here. Perfect square. If you, of course, you have to take minus sign common. It will become x square minus 2x. Okay. To make this perfect square, you have to what? X square minus 2x plus 1 minus 1. Correct now? Have a look. I have 2x minus x square, right? It will become what? X square. I'm taking minus sign common. X square minus 2x. This whole thing will become x minus 1 the whole square. This will be plus 1 outside. Okay, that one will become with 4 plus 3 as 4. So I'll have 4 minus x minus 1 the whole square. Apply the formula, you'll get the answer. Please check. This is the form. So you'll have x minus 1 by 2. So this is not there, either A or C. And you'll have a square by 2. What is a square? A square is 4. A square by 2. So 4 by 2 is 2. A is not there, option is C. So see, I've got this question right. If you know the formula correctly, I'll repeat myself. Basically, they have given you this, right? You need to make a perfect square to apply the particular functions. Superb. Take minus sign common over here in the last two terms. You get x square minus 2x. Add plus 1, remove minus 1. Why? To make a perfect square, you get x minus 1 the whole square in the first three terms. Minus of minus 1 becomes plus 1. This plus 1 will be added with 3 becomes 4. What I have? 4 minus x minus 1 the whole square. Formula, root of a square minus x square integration. Remember, particular function, x by 2, the same root repeats. Then we have what? Then we have plus a square by 2. So x by 2, what is x over here? X minus 1. So x minus 1, we can't have option B is gone because it is x plus 1. So A or C. What's the second step? Plus a square by 2 sine inverse of this x minus 1 by A, okay, by 2. Okay, so what we have option? Of course, 2 sine inverse, right? A square is 4, 4 by 2 is 2. So we cannot have just 1 over here, which must be this option. Option C is correct. So no need to solve the question, simply option will be helping you to get the answer if you know the formula. This question is not a homework because I already did it. Please try again. So very important to solve all the questions that I've done today, no? One more time. Very important to solve all the questions that I've done one more time. Okay, this is very much clear. Clear, okay? Have a look. Question number 16 now. Question number 16 now. Okay, this is the homework. In this case, what you're gonna do? Take 9 common. It'll become what? X square minus 4 by 9 in the root. What I have? Root will come out as 3. So I have 3 in the root. Now x square minus 2 by 3 the whole square. Apply the formula now. Apply the formula. Okay. You'll have log in this case. Log plus log, right? Check this out. There's a homework. This completes the session today. That's it from the, what is it? By parts, partial fraction and particular function also. Particular functions as well. All three is discussed in detail. Difficult question, challenging question has been discussed. I hope you had fun. And not only that, I have also given you homeworks. How many questions? I've given you a total of 10 questions as homework. Please check. Okay, check over here. These are the 10 questions as homework. You need to solve all these 10 questions. Okay guys, there are a total of 10 questions as homework given to you. Do not worry, I'm also going to give you a video solutions for all of this. But right now, you have to download the class notes to solve this homework and the question I gave you in the class practice as well. So practice questions and homework question has to be solved for this particular topic, which is particular functions, partial fractions or by parts. They are very important, very crucial. 3 questions can come from here and you might miss out on that, whether it is KCET or PU2 also. So you have to make a promise that you're going to download the PDF and then solve all the problems, whatever I have solved and whatever I've given you as homework. Please make a promise. And if you're new to the channel, I'm telling you, like this, we study. Over here at this platform, we study seriously. Okay, that's why we get the results also. Just this YouTube channel has produced superb result, toppers of KCET. Okay, so if you are very much serious to get a very good rank, be a topper in the next year, follow our content very rigorously, follow our words, practice the question that we gave you as homework or the class session notes. Practice these, you'll be very much prepared for your examination, whether it is PU2, whether it is midterms, all of that will be covered in our channel itself. Okay, so this is clear. Today's agenda: homework is given, 10 questions, class practice also given. I have solved questions, you need to solve them again, because question will not become less lengthier. Okay, you will not have tricks in all the problems. The trick is to solve those steps in your mind. It takes, you can do it faster. You have to increase your processing speed. If you are feeling that right now, sir, I'm not that student, I'm not that topper, it's okay. You don't have to be the topper to understand the question in your mind. Start practicing. Write this question 5 times. You can see the steps will keep coming to you straight away. Okay, that's how even toppers are made. Toppers don't, get, let's say this is the, okay, my first year as topper sir, attendance in my classroom, I'm a topper sir because I'm a topper. No, they have done this. They have done this great grunt work. When you were sleeping, when you were playing, that student who is a topper right now was solving the same question 10 times. Was understanding the concept 10 times. Got that clarity. So topper has worked a lot to get where they are today. You can do the same thing. You can achieve the same result if you are promised to yourself, if you are very much, like committed to yourself. You can do that, bacha. Okay, I'm telling you, you can do that. Just believe my words. You can be the same guy in the next 2-3 months if you have worked hard for the next 2-3 months. Okay, so I think this is enough. I had teaching you. I told you my favorite topic is integration. When I teach, I get more energized and I have more inputs coming from my side for all of you. So please make sure that you are making the most of it when I'm dealing with this chapter. I'm telling you, it will not be taught in this detail again, okay, on our platform. So when I'm teaching you right now, please make sure that you are solving all the problems, watching the entire video, getting all the concepts cleared. Okay, make a promise to me and to yourself that you're gonna understand integration with me right here. Doubts you have, let me know. Whenever I can, I'll come up with a live session to discuss a live. If you have enough students, if all of you want me to do a live session to discuss doubts of integration, I'll do that as well. So let me know all of your feelings about this chapter. 7 questions, 7 to 8 questions. If you include the question of AOI, 8 to 9 questions from this chapter itself, integration. Right, and again it has the similar amount of weightage in the case of PU2 also. Let's say 3-4 marks in PU2, 5 marks in PU2 from integration, and here 7 marks, 12-15 marks. Okay, even PU2 marks counts, right? So 12 to 15 marks from this chapter itself for your KCET. PU2 marks count in KCET though, that's why it's very, very important. Please pay attention to this chapter. I'm telling you, it's okay that it's difficult right now, but with practice, you can achieve that sense of understanding and comfort in this chapter as well. So with this, I can end the session today. I'll again see you very soon. Till then, take care. Bye-bye.